The interstellar visitor has returned, but this time, it shines brighter, its light cutting across the dark silence of space like a whisper from another galaxy. It glides through the void, a glowing wanderer carrying the memory of another sun, its frozen trail stretching like a cosmic signature across the heavens. The idea that an object from interstellar space could strike Mars is astonishing, a thought that challenges everything we believed about our calm, predictable solar system. Comets were once seen as harmless drifters, beautiful but distant. Yet this traveler, feels different. It carries mystery, speed, and purpose. From the first faint signal, astronomers around the world rushed to their telescopes. They recalculated orbits, refined data, and watched as the truth emerged. This visitor might not just pass by, but collide with a planet. Born around another star, forged in an alien cradle of ice and dust, it has wandered through space for ages. Now, after eons of drifting, it has entered our solar system, and its path seems aimed at Mars. It feels like a story written by the cosmos itself, a drama of collision and revelation. Before we continue, remember to like and subscribe, because what follows may change how you see the universe. This object is known as 3I Atlas, only the third interstellar body ever detected in our solar system, after Oumuamua and 2I Borisov. But even among these rare visitors, 3I Atlas is unique. Its orbit is hyperbolic, its eccentricity far greater than 1, proof it was never bound to our Sun. It truly comes from the beyond. Infrared data from the James Webb Space Telescope reveals a coma rich in carbon dioxide but poor in water vapor, evidence of formation in a distant, colder world. As it moves closer to the Sun, its path aligns almost perfectly with the plane of the planets. Instead of passing safely by, it crosses dangerously close to Mars' orbit. Each new calculation narrows the gap. Its perihelion, the point nearest the Sun, lies between Earth and Mars, and the projected distance to Mars keeps shrinking. Webb's precise instruments tracked every flicker of light, every trace of motion. The data now points to a shocking possibility. 3I Atlas might be on a collision course with Mars. Even in astronomy, where caution is constant, the idea of such an impact feels unimaginable. The scale of this event would be immense. Mars, the red planet we've studied for decades, home to rovers, orbiters, and future human hopes, could face a visitor from another star. Picture it. A frozen giant racing through the void at tens of kilometers per second, releasing energy beyond anything humans have ever known. If it strikes, the explosion could reshape the surface and sky alike. The crater, the shockwave, the clouds of dust, even Mars' thin atmosphere would tremble. But with destruction comes discovery. A collision could scatter alien material across the Martian surface, a natural sample returned from another star system. Scientists would rush to study the crater, the debris, and the changes in the atmosphere. A nearby rover might even capture the impact, a brief flash marking a meeting of two worlds. Still, the risk is real. Debris could threaten orbiters and satellites. Even fragments of the comet might create smaller impacts across the planet. And yet, hidden in that danger is a profound opportunity. For Mars might soon hold fragments of a world. As the reality of the possible impact grows clearer, the world's observatories enter a new state of urgency. Across continents, telescopes turn toward the same point in space, all tracking the same faint moving light, the interstellar visitor known as 3I Atlas. In control rooms lit by glowing monitors, teams of scientists work around the clock. Data streams in from Hawaii, Chile, and orbiting telescopes, each transmission refining the object's path and narrowing the uncertainty. NASA, ESA, and JAXA coordinate in constant contact, their communication lines buzzing with updates. Every recalculation seems to whisper the same possibility: the comet's trajectory continues to converge with Mars. The James Webb Space Telescope, perched a million miles from Earth, records light curves and spectra with astonishing clarity. Its readings reveal subtle changes, gas jets bursting from beneath the comet's crust, tiny shifts that alter its motion ever so slightly. But even these small deviations fail to guarantee a safe pass. If impact truly occurs, it would mark the first collision ever recorded between a planet in our solar system and a traveler from another star. It would be an encounter of cosmic proportions, a handshake between worlds separated by light years. Scientists are preparing for both outcomes. If it hits, they will study how interstellar matter reacts to a planetary surface for the first time in history. Seismic sensors on Mars could capture the vibrations of an alien impact, offering insights into the planet's crust and mantle. High-speed cameras aboard orbiters would watch as a brilliant flash blooms across the surface, followed by a column of dust rising like a gray flower against the red horizon. Minutes later, shockwaves would ripple through the thin atmosphere, and instruments would measure how dust disperses in the planet's low gravity. If it misses, scientists will still gain something extraordinary: a direct reading of interstellar gases, icy fragments, and organic molecules passing through our inner solar system. Some of these particles might even settle on Mars' atmosphere, creating a subtle, measurable change in its chemical balance. Mission planners are already simulating both scenarios. Mars orbiters like MAVEN, Odyssey, and ExoMars Trace Gas Orbiter could face streams of debris capable of damaging solar panels or sensors. Protective maneuvers are being tested, including repositioning orbiters to safer trajectories above the equator and placing surface rovers into standby mode as the object approaches perihelion. For engineers, this is a delicate dance, balancing exploration and protection, data and danger, science and survival. Yet amid all the technical planning lies something deeply human, a feeling of awe that our species is alive to witness such an event. For centuries, humanity has looked outward searching for signs of life, for meaning, for connection. Now, for the first time, the universe has answered, not with a signal or a light, but with motion, sending a messenger across the void. 3I Atlas could be more than ice and rock. It could carry molecular fragments from a system older than our own, carbon chains, amino precursors, the raw ingredients of life itself. If any of that material survives impact, it might seed Mars with compounds that once drifted between the stars. Imagine what future explorers might find: tiny crystals embedded in the crater walls, compounds unknown to Earth's laboratories, chemical fingerprints of another world. It would mean that the building blocks of life are not bound to one solar system, but scattered freely through the galaxy, a cosmic inheritance waiting to be discovered. Astronomers also know this. Whether the comet strikes or passes safely, it will reshape the way we study the universe. For the first time, we are not just observers of interstellar matter. We are part of its journey. And so, telescopes continue to track, satellites continue to measure, and the world waits. Every hour brings us closer to the encounter. Somewhere beyond Earth, in the silent cold of the void, 3I Atlas races forward, its frozen surface reflecting sunlight, its gases venting into space like the breath of a sleeping giant. In a few short weeks, it will meet Mars face to face. Whether it grazes the atmosphere or plunges into the surface, the moment will echo across time, a reminder that creation and destruction are both woven into the fabric of the cosmos. And perhaps when the dust settles and the instruments quiet, we will finally understand that the universe has never been distant or silent. It has always been reaching toward us,